Thank you for viewing this recorded Reliable Automatic Sprinkler Company webinar. Should you have any questions regarding this presentation, please feel free to contact Reliable Technical Services at 800-557-2726 or email us at techserve@reliablesprinkler.com. For upcoming webcasts and an archive of past webcasts, please visit reliablesprinkler.com/webcasts. Once again, thank you and enjoy the presentation.
Well, again, welcome everyone from Liberty, South Carolina. On behalf of Reliable Technical Services and everyone at the Reliable family, once again, we hope that you and your families are staying healthy and well during these trying times. As Steve mentioned today, we're going to talk about in-rack options independent of the ceiling design. So always a question with presentations, where do we start? We're going to spend a lot of time and a lot of energy talking about the protection of plastics during this. And one of the things that's happened in the industry is the protection of plastics. You're actually kind of getting class 1, 2, 3, and 4 underneath it in most of these options now. So plastics has been kind of the driving force. The first plastics, synthetic plastics, were developed as early as 1907. It was called Bakelite. But it wasn't until 1950 or so when we really saw plastics take off in the world. You can see on the chart here, 0 to 380 million metric tons of plastic between 1950 and modern day. To put that in perspective, if you took 2/3 of the world's population and put them on a scale, you would have roughly 380 million metric tons. So the prominence of plastics in the world today, as everyone knows, is going to be driving a lot of our discussion moving forward. Up until recently, there's been something missing in the standards. We've had protection schemes, obviously, for class 1 through 4 and Group A plastics for a number of years, going all the way back to the NFPA 231 and 231C days. Those documents were blended in with NFPA 13 in 1999. There had been protection schemes, again, for Group A plastics with some exceptions. And that exception primarily being the protection of exposed expanded plastics. We did have protection schemes for small limited heights, 5-foot heights. So we found those in the miscellaneous storage section. But the full-on storage of exposed expanded plastics has been missing. Before 2016, this is what the decision tree looked like. You worked your way down. And as you can see there on the left with the green check mark, cartoned expanded or unexpanded and exposed unexpanded, we had protection schemes in NFPA 13, but we did not have protection schemes for the high piled storage of exposed expanded. Those were simply outside the scope. In the 2016 edition, however, we did get some direction. And that direction now shows up on the decision tree. Expanded plastics protect only using the portions of Chapter 17 applicable to the exposed expanded plastics. What exactly was that? That was an effort that was undertaken by the Fire Protection Research Foundation, the research wing of NFPA. And they essentially did some testing and validated a scheme that would allow the protection of exposed expanded plastics over 25 feet, as well as obviously under 25 feet. The test parameters were a 35-foot storage in a 40-foot building, 8-foot aisles. And the interesting thing the interesting aspect of the scheme was the use of vertical barriers. The vertical barrier was installed at every other rack upright, about 16 feet between. There was some constraints put on the area, the 124 square feet. K25 sprinklers at the roof, 12 sprinklers at 60 psi. So large bore sprinklers flowing at high pressure. Again, remember this is ceiling only. And the idea here was to create essentially a chimney to take the heat from the fire take it directly to the roof as quickly as possible, activate those fire sprinklers as quick as possible, and then force that fire back down in that same chimney or chute, if you will. 12 sprinklers at 60 psi, however, 2,600 gallons per minute. So yes, do we have something that's feasible? We do. Do we have something that uses a lot of water and large piping and fire pumps and things like that? Absolutely. So that was one option that came in 2016 in Chapter 17. Factory Mutual data sheet 8-9 also has a ceiling-only design criteria for exposed expanded. Again, 40-foot high building, 25K storage sprinklers, quick response storage sprinklers, an expanded area of 20 sprinklers flowing at 75 PSI. No barriers, which would explain the expanded area, and again, higher pressure by 15 PSI. Do the math on that one, you're going to end up almost 5,000 gallons per minute. So again, feasible, large pumps, large storage tanks if you have them, and a large piping to go along with it. We also in 2016 got some information on how to protect mixed plastic products. So again, not necessarily the full-on storage of exposed expanded, but products that used a combination of hard plastic, soft plastic, metal, wood, things like that. We did get some direction on the protection of those, whether they are exposed on a rack or cartoned in a multi-layer cardboard box. So tables were provided. You can see the one on the screen here for a cartoned commodity. What we're going to do, we're going to take a look at the percentage of exposed expanded plastics expanded plastics by volume. Draw a line at the 40% mark. If it's more than 40%, we're going to protect that as a Group A expanded plastic. And then obviously to the left of the 40% mark, we work our way down into a Group A non-expanded protection scheme, and then depending again on weight and volume down into Class 4 and even down into Class 3 for small amounts of each of those components. If the commodity is not cartoned and is on the racks exposed, that 40% mark marches down to 25%. We're then going to have a protection scheme that protects the entire area as a Group A expanded plastic exposed. And then again, less than that, we work our way down to the Group A non-expanded exposed, and then Class 4, Class 3 as you work your way down. So again, some guidance provided in 2016 on how to do some of these protection schemes. Also, what we got in 2016 was a protection scheme for isolated commodities. I've used a real technical term there, localized stuff in racks. This is for a higher class commodity in limited amounts that can be isolated to a section or a portion of the rack. And these protection schemes will involve either an extended coverage area beyond the square footage of the protected commodity, or it will involve vertical barriers and perhaps a horizontal barrier with sprinklers enclosed within those. We saw some things kind of like this in the big box stores with the storage of paints and paint thinners and things like that in the local hardware stores. We still see things like this happening, but now it's been standardized in NFPA 13. So we worry about exposed expanded plastics. What actually are those? And we need to be careful here a little bit. You can look at the chair on the screen there and definitely understand that that's some type of an exposed expanded plastic within that chair. However, there are other things that we don't necessarily look at and recognize as an exposed expanded plastic. Paraffin blocks is an example. Exposed expanded plastics. It's not squishy. You're not going to put your hands on it and squeeze it, but the characteristics of how it burns are similar to those of an exposed chair that you see there. Car bumpers. So the hard plastic on the front of these is definitely not exposed, but what's right behind there is going to be fairly substantial amounts of almost like a dense styrofoam material that creates that shock absorption capability. So that blend of commodities right there, when you set that on a rack, needs to be treated as an exposed expanded plastic for that reason. And then finally, charcoal briquettes that are impregnated with lighter fluid. Charcoal briquettes by themselves are going to be a little bit less of a hazard. However, when you impregnate them and they catch on fire again, they're going to burn similarly to the exposed expanded chair that you see there as well. So very important, as always, to make sure that the commodity is classified properly, hopefully by the owner and or the insurance company. Make sure everyone's in agreement on exactly what we are protecting, and we need to move forward from there. So a question that we've used in some of our presentations over the years, we've spent the last 30 years trying to eliminate in-rack sprinklers. We all know the pitfalls of having sprinklers in racks. And since the early 80s, mid 1980s, with the advent of originally large drop sprinklers and then ESFR sprinklers, the whole thrust of that was to somehow get rid of the in-rack sprinklers to prevent water damage. So we spent the last 30 years trying to do that. Why are they coming back? We talked a little bit about it, right? The advent and the more higher prominence of plastics being stored in our warehouses. But another feature there is the higher buildings and automated storage and retrieval systems. Higher buildings, number one, obviously more fuel load as you move vertically, more time to get the fire to the ceiling, and then obviously trying to push the energy of that fire back down to the bottom to control the fire. The other thing that happens with these automated storage and retrieval systems, however, is the ability of the computer to find an empty pallet position to put any commodity that it needs to in that spot. So in other words, back in the day, you would take your worst commodity and you would isolate it to a section or a portion of the racks that were designated for that, and you would do some sort of spot treatment, either in racks or some higher density to accommodate that. But now that the automatic storage and retrieval system can take that commodity virtually anywhere in the warehouse, obviously we need to now protect the warehouse to the highest hazard classification. So that's something that's happened over the past few years as well. And then obviously, again, more exposed plastic storage. So we talk about the future of storage and what does that look like? Buildings in excess of 100 feet high. Buildings in excess of 100 feet high that might be storing car tires, for instance. Imagine that bombshell that's sitting there waiting to go off. So here's a kind of a quick picture of what these things may look like. Some distribution, incoming, outgoing products, low storage. We say low, but that could be 35, 40, 45 feet. And then the interior portion, the very, very tall 100 foot high or higher roofs. Oftentimes these are rack supported buildings. So we say the future of storage. However, I had the great pleasure of working on a project in Tacoma, Washington back in 2007, and it was a rack storage building. So not the future. Now 13 years ago, these type of buildings were being built. I would like to give credit to my former employer. You know who you are, if any of you are listening, for the use of these photos and the drawings as well, which I used as part of this presentation. So it's not really the future, it's happening there. This building was protected. This is about a 110-foot tall building, 150,000 square foot footprint underneath it. Around 18,000 in-rack sprinklers went into this building. If you look at the picture on the right, about 1/3 of the way down from the top, looking down through those racks, is the cab of a semi-truck. So that'll give you some perspective on exactly the magnitude of these size buildings. I call this the view from the roof. I got to the top of the distribution area, the receiving area. I don't remember which one it was. So right there, I'm standing 40 or 45 feet off the ground on the roof of the low portion. And again, just to give you an idea of the magnitude of these buildings and the way they're designed. Very, very interesting project. So what's new? This picture that you see here, I don't know why it struck me to use in this way. We had an eclipse here several years ago that was just fascinating to watch. It was kind of interesting watching the day get dim for 10, 15, 20 minutes and kind of thinking, wow, this is it. This is why did I come out here? But it's very interesting when the moon moves directly in front of the sun because it goes pitch dark in literally about 5 seconds. And it stays that way for the better part of a couple minutes. And then the moon moves out of the way of the sun, and again, we're into daylight. So a very, very rapid transition from day to night to day. It's kind of similar to what's happened in the last couple years with the protection of exposed expanded plastics and some of the options that we're going to talk about today. So you're going to hear a lot of talk, and you probably have been hearing a lot of talk over the last several years, perhaps, with regard to what we call the virtual floor. What is the virtual floor? In some cases, it's a combination of sprinklers and a horizontal barrier. And in some cases, it may just simply be the application of a layer of sprinklers that is absolutely so dense that the fire simply cannot get past it. It actually creates a separation vertically as you move your way up through the racks. And the idea is that when things are validated properly, that the fire will be contained within the vertical separations, be it horizontal barriers or that, again, that dense application of sprinklers, referred to as the virtual floor. Now, what is the nice thing about the virtual floor? Steve mentioned it early on. With the options that we're going to look at, we do not have to add or balance the in-rack demand to the roof demand. I've got a picture on the screen there of Mr. Miyagi. You remember the movie, The Karate Kid? That whole movie, if you remember the premise, was all about balance. Life is all about balance here. So when we talk about the in-rack sprinkler protection, we don't have to balance that anymore. If anybody's been in the business for a while and designed one of these in-rack systems, a conventional one before the ones we're going to talk about, we would run through our hydraulic calculations, and maybe it calced out at 400 or 500 gallons per minute, whatever the demand was, and where that connected to the common supply pipe that fed the rest of the building, that demand had to be brought in within 1/2 PSI. It had to be, the pipe needed to be sized. Oftentimes we're doing crazy things like running very small pipe to a lot of sprinklers. It seemed kind of silly a little bit, but the idea was to bring those pressures within 1/2 pound, do a quick K-factor balance, and then take that total demand, ceiling demand and rack demand, back through the common piping, the backflow preventers, the fire pumps, the underground mains, and everything that fed that system. So when we do that, that's going to drive pipe sizes up, fire pump sizes up, water tank sizes up. Not just the material, you're going to have labor that's going to be associated with that as well. So the beauty of these systems, do not add or balance them to the overhead sprinkler system. What has that got us right now? In 2019, in the new 2019 edition of NFPA 13, we have options. Door number 1, door number 2, or door number 3. Let's take a quick look at what those options are. 25.8.1, option 1, as it's going to be listed in the standard, is going to cover everything, class 1 through 4 and all group A plastics, whether they are cartoned or whether they are exposed on the racks. If you have had experience with FM scheme 8-9A, this is kind of what we're talking about here. 12 foot vertically between barriers. Okay, so if we have a 120 foot tall building, we're going to have 9 or 10 vertical or horizontal barriers with in-rack sprinklers below them. We're going to use quick response minimum 8.0K sprinklers. So again, we may look at an 11.2 or something like that to save a little bit of pressure. Sprinkler deflector as close as to the underside of the barrier as possible. NFPA 13 is going to give us some diagrams that we're all kind of used to seeing on what these protection schemes look like for the various types of racks. You can see on the screen a single row rack, maximum 5 foot on center, so every pallet position over the transverse flue space, and a horizontal barrier to accompany that. For double row racks, we're going to go down the longitudinal flue space, a maximum of 10 feet on center, face sprinklers at a maximum of 5 feet on center, again with a horizontal barrier. Multiple row racks becomes a kind of a permutation then of the double row racks. Face sprinklers and then alternating longitudinal flue spaces, either 10 feet or 5 feet on center. So again, a relatively dense application of conventional, I would say, small bore or smaller bore fire sprinklers with those horizontal barriers, 12 feet on center. You have a pretty flexible system that will protect virtually anything that wants to go in there. What does the water demand look like? So I want to take a second and just let you know what we're going to see at the end of the presentation here. I'm attempting to build a comparison between options 1, 2, and 3 and put them into a building, a mock building, so that we can then see how many fire sprinklers in that same size building. Hopefully this will become clear in a little bit. And again, this is all based on the project that we saw that I worked on in Tacoma here. So what do we do for water demand for option number 1? 60 gallons per minute times 6 sprinklers in a single row, 60 gallons per minute times 8 sprinklers in double and multiple row. Pretty straightforward information provided there. If we look at the pressure, then work our formula, Q equals K times the square root, reformat it and figure the pressures out, we can see that the 8.0 K sprinkler is going to take 56 PSI. That may be a little bit problematic. So in this case, we might look at the 11.2 K sprinkler. I'm going to choose that because this is the build that I'm working on to make the comparison at the end here. So keep these numbers in mind, and we'll see them at the end of the presentation. 25.8.2 option 2 is also brought to us courtesy of FM. It covers a couple of different things here. We got to now start breaking this down a little bit. For class 1 through 4 and cartoned non-expanded group A, we're now going to jump that 12-foot spacing up to a maximum of 40 foot between sprinkler levels. And if we have cartoned, expanded, and all exposed plastics, we're going to drop that back down to 30 feet. And again, this is all the result of testing that's been done in the real world. Minimum K14 pendant ESFR sprinklers. Pendant being an important part there. Minimum K14 with a condition, we'll see, again, we're going to have some options and some requirements to go larger, but K14 would be the absolute minimum, and then a minimum of 6 inches top of storage to the deflector. Again, we're going to look at our diagrams to understand the spacing. For a 3-foot maximum depth single row rack, we're going to go right over the top of the pallets, 4.5 foot on center maximum. So again, every pallet position. If the depth of the single row rack goes up to 6 feet, we need to do a stagger front to back across the single row rack. And as anyone that's designed and installed knows, when we start getting into staggers and things like that, our complexity of our design, our installation, our fabrication has just gone up proportionally. And then again, we can see a single row rack against the wall. We're allowed to move that staggered rack back into the space between the wall and the back of the rack. The double row rack installation, again, 8.5 feet on center max between sprinklers on the face, and then a dense layer of sprinklers down the longitudinal flue. That's for a maximum 9-foot rack. Once we go over the 9-foot double row rack and up to 12 feet, And this is where the sprinklers get very, very dense. We can see face sprinklers and longitudinal flue sprinklers at a maximum of 4.5 feet on center. And remember, these are ESFR sprinklers. And also remember, we are not using a horizontal barrier in this condition. So that dense layer of sprinklers that you can see in the bottom is going to absolutely prevent that fire from escaping. We get questions quite often, what about cold soldering with these type of systems? The reality is that if you do have cold solder, you're not necessarily needing to have water discharged out of that sprinkler. If the fire gets hot enough, it potentially could set that sprinkler off, and it will come into action if it's required to. But again, we're not worried about cold solder in this condition, nor are we worried about the minimum 8-foot spacing for ESFR sprinklers. Multiple row racks, as you can see, the face sprinklers, we now take those out to 8.5 foot max on center, so that would be at your rack uprights. And then any longitudinal flue space is going to have fire sprinklers at half that spacing down there. And then the numbers that you see on there, you're given some guidance on which sprinklers to calculate when you do your hydraulic calculations. So again, we have a chart now provided for the number of sprinklers to calculate. Single row racks for the first option, the 40-foot option, we're going to have 4 sprinklers. Actually going to have that for both of those options. And then again, you can see in the table 5 sprinklers, and then for double and multiple row 6. And if it's exposed, we're going to do 6 and 6. These numbers may be changing in the next edition, but not by much. One thing to keep in mind in the next edition of NFPA 13, which will be 2022, it's very likely that all 3 of these options are going to be brought together into one chapter. So this is going to get even a little bit more simpler to understand, a little bit more simple to understand. And you'll see again this change being brought forth if it passes in the 2022 edition. So we're going to take a look at double and multiple row racks. Again, this is kind of what we're going to build our comparison around. Here are our flow rates that are provided by the standard for the 30-foot and the 40-foot spacing. And again, you can see at the 30-foot spacing, a minimum K14 for the lowest hazard commodity. And then for the 40-foot spacing, minimum K factor of 22.4. And you're going to get the gallons per minute associated with each of those. So we're going to take a look at class 1 through 4 carton non-expanded. We're going to take a look at the water demand as an example. Again, these are not singular. There are many, many options to work your way through. Again, we're simply building hopefully a comparison. 120 gallons per minute times 6 sprinklers in double and multiple row equates to 720 gallons per minute. In this case, since we have not a lot of difference between our pressures, and because we had 29 psi in the last one, I'm going to select that as the option. And one of the things that you're going to see from manufacturers is the provision for guards and shields now for the either the standard spray sprinklers and actually as the ESFR sprinklers as well. So we'll have the ability to use those listed for in-rack use only, not for use at the ceiling or under obstructions. 25.8.3, option 3. Before we talk about that, we're going to take a little Rocky Horror Picture Show time warp back in time. We're going to go back to 2012 at Reliable Automatic Sprinkler Company. The goal in 2012 started with an idea to provide protection schemes for storage arrangements currently beyond the scope of NFPA 13. They simply did not exist. We knew that they were out there. We knew that they were being built, but there was no protection schemes standardized anywhere. So the idea here was to look at coming up with the scheme to protect those. Where there were schemes for the protection of class 1 through 4 and non-expanded plastics, either provided by NFPA 13 or factory mutual, were there alternatives that had not been proposed or validated? But the overriding goal here was to do all of this and come up with an overall lower water demand. Remember the two schemes, the 2,500 gallons per minute roughly and the 5,000 gallon per minute schemes for protection of exposed expanded plastics. Is there a way to do that with lower overall water demand, to reduce the size of the pipe, reduce the size of the backflow preventers and the fire pumps and the underground mains and the water storage tanks if they were needed, and the associated labor that comes along with those? So those were the goals back in 2012. To date, Reliable has run 8 tests. Had the first one failed, we may not be sitting here today, but the first one went very well, as we'll see here in a little bit. So 8 tests given different commodity classifications and storage heights and different variations to try and validate some design parameters for the industry. The big idea, and we say big idea in terms of the K factor. 25.2 K factor sprinklers in racks, kind of unheard of. If you're going to break a fire sprinkler off with the forklift, you would probably like to break off a 1/2-inch fire sprinkler, I suspect. Now we're talking about putting large K factor sprinklers in there. Obviously the water demand, the water flow out of those is going to be much higher. What's the flip side? Hopefully there are going to be far fewer of them as targets for the forklift operator. What was the other idea? The other idea was the use of the horizontal barriers, a scheme that had been somewhat validated by Factory Mutual with their 8-9, as well as extended coverage. So again, not just a big bore, but extended coverage, and we'll see why that idea was important here in just a bit. The end result of this became known as the Reliable NRAC EC Extended Coverage NRAC Sprinkler System. Information about that system is available on the website or by contacting technical services or your local sales rep. So why the N252 EC? If you are at all familiar with the use of combustible concealed space sprinklers in shallow areas 36 inches and less, this concept will come right to mind. The reason that we are required now to do that and have been for several years in combustible concealed spaces is because the standard umbrella pattern of a standard spray sprinkler does not open wide enough before it hits the flat surface below it. So we needed to come up with fire sprinklers, all the manufacturers have them, with a flat spray pattern trajectory that allows that pattern to open in those very shallow spaces. So now take that concept above the pallets that are in these racks. When we put standard spray sprinklers in there, we have the same result. The umbrella pattern simply does not open, and we don't get the water out to where we need to. The flat spray pattern trajectory of the EC sprinkler allows that water to eject from the shallow space between the load beams and the top of the commodity, and in a lot of cases actually penetrate into the target arrays on either side. And we're actually going to see a demonstration of that in a video here in just a second. The horizontal barriers, what do those look like? 3/8 plywood or better. The horizontal barrier is not there to not burn. It is simply there to capture heat and aid in the activation of the fire sprinklers. And you can see in this case we're allowed the 3 or 3.5 inch gap. I don't remember exactly which one it is, but a small gap at the rack uprights to facilitate ease in setting those barriers into place. What does the piping look like? Very conventional down the longitudinal flue space. In the case of the testing, the fire sprinklers were broke off to the side and then elbowed down. That was to save some deflector height as opposed to an outlet right in the bottom of the pipe. The pipe's going to be generally a little bit larger depending on your pressures and your hydraulics. In this case, I think that was either 2.5 or 3 inch pipe running down the flue space. But the layout very similar to what we would do in years ago with maybe smaller pipe and smaller fire sprinklers. So what did the test parameters look like? Again, at the time we were trying to match the best information that was available out there in the marketplace. In this case, for the cartoned unexpanded, it was 43 feet of storage in a 48-foot building. We installed a horizontal barrier at the 30-foot level. We pulled the aisles within 4 feet. to save some to make the use of the space a little bit more attractive to the building owner. And we used EC pendant sprinklers at the roof. In this case, you'll see that they showed 0 psi. Those were turned off. Obviously, they were able to be made active in the event of an issue. But remember, the idea here is to capture that fire and control it underneath the horizontal barrier. The results of the test: the fire did stay within the horizontal barrier. We did not operate any ceiling sprinklers. 3 in-rack ceiling sprinklers operated within 1/100th of a second of each other. It was very, very quick. Remember, these are very, very sensitive, quick response sprinklers. And then the ceiling temperature allowed to get up in the 1,000-degree mark, barely got warmer than a summer day in there. Very successful test. We're going to show you a video of the test right now. And I'll do some narration. If everything works, the sound should be off on the video. And last time we did this, we had a little bandwidth issue, but we'll see what happens here. We're going to get the video started. In the upper left is a GoPro camera that's looking at the underside of the horizontal barrier, and then we're going to watch the video here. And it's about a 2-minute video. As the joke goes, these are the professional arsonists at UL. Again, cartoned, unexpanded plastics, 43-foot high, 48-foot building. The horizontal barrier in the upper left GoPro view is at 30 feet. At around the 30-second mark, you're going to see some smoke wisping out of the flue space on the underside of the barrier. A little bit further in, you'll start seeing some embers. I call them fireflies, kind of floating out from the underside of the barrier as well. Fire's continuing to grow. You'll see a few more embers, some more smoke, and then around the 1-minute mark, we're going to see the fire actually hit the underside of the barrier, turn sideways. And again, at the 1:14, 1:15 mark, we're going to see the fire sprinklers operate. And see the immediate effect it has on crushing that fire. The camera's going to move around a little bit here. If you take a look on the left side, on the right side, you can actually see the water is making it through the target array onto the floor through the target array. That's going to happen on each side. So very effective penetration of water onto the target arrays. We're pre-wetting all of those combustibles. Remember, pre-wetting, a very, very important part of the fire control. Wet cardboard, extremely hard to ignite, so we like to get it wet. And this test runs for another few seconds here. In the real world, they would let this go for 30 minutes if necessary to make sure that fire stayed under control. But again, extremely, extremely successful test, which then prompted us to do more. Here's what the fire damage actually looked like from that test. And so imagine this with the vertical barriers. You'd have kind of the same end result, so to speak. Although the fire damage for the vertical barriers was a little bit more because that fire again had to burn clear up to the roof. A very classical burn pattern where the pyramid kind of starts. The base of that pyramid at the top is where the horizontal barrier is at. Another test we ran was for exposed expanded. So we took the success that we had. We got a little bit crazy and thought let's try taking this to the next level. We picked another protection scheme that was available. I believe the protection scheme on hand at the time was a 0.8 over 2,000 density, 27 feet of ceiling height, 20 feet of storage on multiple row racks. We pulled the barrier down to the 20-foot level. Pulled the aisles in again to 4 feet and used the same exact concept, and you can see the end result there. 5 sprinklers operated, 4 of them very early, and then a 5th one at some point later on in the fire. and again, a very limited escalation in ceiling temperature. This is what the test looked like. It's a very, very scary test when you have that much commodity stacked together, particularly with the 4-foot aisle widths. And here was the piping detail. So we knew we'd have to have the longitudinal sprinklers. We also knew we would need face sprinklers in this test, and so that's what the piping layout looked like. We often get asked, does it have to look like that? The answer is no. Fire sprinkler contractors, designers, fitters are very creative. You're going to be told where the fire sprinklers need to be and what pressure needs to be at that fire sprinkler. How you get them there is entirely up to you. Here was the fire damage following that test. It may look extremely bad. However, I suspect if you're a building owner responding to a call that you had a fire at your facility that was storing this kind of goods and showed up and this is what you found, you might be very happy. So again, very, very successful test. The concept of the horizontal barriers, the extended coverage sprinklers, very, very, very effective. So let's move back now to a couple years ago with the standards process and bringing that test results and moving them into NFPA 13. It's all done through the standards process, the discharge committees and installation committees and things like that. It now becomes option number 3, door number 3. And again, similar to the FM ESFR scheme, we're going to have 2 vertical spacings to look at. This one will use a horizontal barrier. Remember, option 2, very dense sprinklers, big bore, no horizontal barrier. We are going to have a horizontal barrier. In this case, class 1 through 4 and cartoned plastics, 30 feet between barriers. If we expose either the unexpanded or the expanded plastics, that vertical interval is going to drop to 20 feet. K25.2 pendant EC sprinklers, intermediate temperature. Sprinkler deflector as close as possible to the underside of the barrier and a limitation of a minimum of 6 inch between the top of storage and the deflector. And again, remember, we need that space to be able to get that water out of the top of the array and over into the aisles. Here's what the installation will look like. The single row rack, as opposed to being at every pallet position, is going to be at the transverse flue space. Every other pallet position, not at the rack uprights. That would have been the conventional way of doing this years ago with the conventional rack system, would have been to have the sprinkler kind of hidden between the rack upright. In this case, we're going to move them, shift them 1 pallet position and put them between the rack uprights at a maximum of 10 feet. For single row, they can be centered or pulled back to one edge or the other. The double row rack is where the beauty really starts to occur in terms of number of fire sprinklers. Again, you're going to see nothing more here than the same way we treated a single row rack. We're going to pull that line of sprinklers to the longitudinal flue. We're going to have fire sprinklers spaced at a maximum of 10 feet on center down the longitudinal flue. Again, with the multiple row racks, we're now going to go into the longitudinal flue space at a maximum of 10 feet, and then face sprinklers 10 feet as well. And then there's going to be a stagger there, as you can see, and a maximum of 15.5 feet depth of the multiple row racks. Water flow demand, these are going to be flowing at 30 psi. That's going to equate to 138 gallons per minute. Single and double row, we're going to do 4 sprinklers. Multiple row, we're going to do 8 sprinklers. You can see the overall water demand for both of those systems without overflow. Those numbers will go up just a little bit, of course. And then the pressure, again, for the 25.21 option, 30 psi. So let's keep those numbers in mind as well. So what have we done here now? We've looked at 3 options that are going to cover the same type of commodity using their particular attributes, either horizontal barriers and 12-foot spacing, ESFRs at 30 or 40 feet, and then K25 ECs at either 20 or 30 feet. And we're going to build a comparison based on a project, a real-life project. And the project is going to look like this: 150,000 square foot floor area, 120 feet tall. Why do we pick 120 feet tall? We pick 120 feet because that is the number that 12 feet, 30 feet, and 40 feet all go into equally. So it allows us to actually build that comparison. What I did was take the drawings that I had, lay out the fire sprinklers for all three of these options, count them up, and now we can kind of see exactly what this comparison looks like. So for a multiple row option, we'll rip the Band-Aids off here. Option number 1, 29-pound end head pressure, 54,000 fire sprinklers in 18 million cubic feet. I think, at least from my standpoint, when you start talking about buildings that are very tall, that have vertical layers of fire sprinklers, square feet makes no sense anymore. Historically, fire sprinklers, everything in terms of square feet, right? Square feet per sprinkler, hours per square feet, dollars per square feet, et cetera, et cetera. That metric can no longer apply when you're into multiple vertical layers of piping. So what we're looking at here is coverage in terms of cubic feet. 330 cubic feet per sprinkler, a total overall sprinkler flow of 480 gallons, and an overall water demand, pure water demand of 57,000 gallons. Option number 2, again, 29 PSI, roughly 1/3 the number of fire sprinklers, therefore roughly 3 times the coverage, 973 cubic feet per sprinkler. Sprinkler water flow escalated a little bit. Remember, this is the ESFR option, no horizontal barrier. So that would be the trade-off here between options number 1 and 2. You're going to have a little bit more overall water demand, but no horizontal barriers. Option number 3, the NRAC EC with 25.2 K-factor EC pendants, 30 PSI. Again, roughly half the number of sprinklers as option number 2, double the coverage area. However, because of the test parameters and the flow required, an escalated 1,104 gallons per minute. So the number on the far right, think about that in terms of potential water storage multiplied times your duration, and you can see how those would impact a water storage tank. So multiple row is one thing. Remember, our overall water demand may be driven by the roof system, and we'll talk about what that roof system needs to look like in a little bit, but we need to be looking at which one, either one or the other, is going to drive the size of fire pumps and storage tanks and things like that. Because why? We don't have to add this rack system with the overhead sprinkler demand. Let's now take a comparison and look at double row racks. Option number 1, not a lot of change there. 317 cubic feet per sprinkler, 58,000 gallons per minute. Nothing much changed there. Things change a little bit with the ESFR system. The number of fire sprinklers goes down, coverage area goes up, and sprinkler flow essentially staying the same. But this is, again, where the beauty of the NRAC EC is with the single and double row options. And we're going to see what those numbers look like here. 30 PSI, very comparable to the 29 for the other 2 options. Fire sprinklers now very, very limited in number, less than 5,000. Coverage area jumps way up. Sprinkler water flow a little bit higher than option number 1, but not excessively. So in the double and single row world, that NRAC EC K25.2 option, very, very attractive. Remember, we do need the horizontal barrier to go along with that as well. So what about the roof? What do we do with the roof protection? The language in NFPA 13 is very clear. It also drives home the point of the virtual floor concept. The ceiling level sprinkler system is designed based on the highest commodity hazard that is not protected by the NRAC sprinkler system outlined in 25.8.1, 8.2, or 8.3. So we simply go to the top level of protection as we work our way vertically through the racks, and we look at what's left. So in the case of the picture on the screen, if those are 5-foot pallet heights, we have about 15 feet of exposed expanded plastics. We would then look at the distance between the virtual floor and the roof, and we would protect that with possibly an NRAC EC or an NRAC scheme, excuse me, an extended coverage scheme, or perhaps an ESFR scheme up at the roof. The beauty, one of the other beauties of this system, if this is a retrofit or a repurposing of a building, or commodity creep has come into play, We can take that virtual floor and we can manipulate it at the top level to make the roof system applicable. In fact, you could cover and cap off the storage if you wanted to, and work with your AHJ on what exactly are we protecting at that point. Maybe we pull the virtual floor to the bottom of the first pallet position. If it's 5 feet of cartoned or exposed expanded storage, we look into the miscellaneous section and we protect pull out an extra hazard group 2 or something like that, whatever that is. But the reality again is we work from the top level of virtual floor and protect what's left. Very, very simple concept. So one final thought that we want to take a look at here is what you're seeing on the screen, and you've probably have seen these before. Very popular with the government back in the day, and with other manufacturers, a sawtooth roof building. And what they liked about these was the ability to bring natural light in through the clear story windows, the vertical portion of that. As we all know or should know, storage is currently limited to a maximum roof slope of 2 in 12. So when these buildings, these very tall buildings, oftentimes are being repurposed for storage, owners, developers want to know, how can I protect this? Until we had options such as the virtual floor concept, the option would be very limited. Either you could not do what you wanted to do, or you would have been required to install a flat ceiling throughout this space, which, let's face it, is not a real feasible option for most developers, nor is it very feasible for storage occupancy. So now with the options that we have, we theoretically could move the virtual floor to the top, cover the top load of commodity, and then essentially the existing roof system, whatever it is, if there is one, may be able to stay. And we protect everything below it using one of the options, either 1, 2, or 3. So now we have a really good way to look at protecting sloped ceiling spaces, and until such time as we have some better direction in the industry on how to do that. So everybody, that is the presentation for today. In-rack options independent of the ceiling system. Again, if you have questions, send them in through the Q&A panel. If you're watching a recording of this, or if you have questions that occur to you later, feel free to direct them to us at 800-557-2726, or you can reach us via email at techserve@reliablesprinkler.com.